Amazing time, guys. If you're remotely interested in at least a little bit of computer science and cognitive sciences, you can literally, with almost no money, do your own studies. And one of the major shifts that is happening in regards to being able to look at huge amount of data and doing it in a way that you can actually do your own research, but if maybe you're not experimental psychologist or experimental cognitive scientist, you can just do a series of very interesting research, depending on the topic that you're interested in, as a computational neuroscientist. And the difference there is that computational neuroscientists, they don't necessarily go into the lab and they actually perform those studies, but they get the data, and more data is becoming more available, both from different institutions as well as different scientists or people who just like want to open source everything. And then basically based on that data, you can design your own sort of codes. And, in this case, let's say Python. And you can essentially conduct your own studies and potentially even write a paper about it. And so there are a lot of ways. And one of the easiest data sets, I shouldn't say easy, it's not easy, it's still very hard, but easier than others is actually the data sets of EEG, because they're more straightforward when it comes to actually gathering the data, and you're able to sort of make them a little bit more structure. So when you feed that into your, let's say codes in terms of, let's say pattern recognition, etc., it's a little bit easier to make that happen, as opposed to, let's say, if you just had neurons or feedback from neurons. So I was just reading a paper during the weekend, and I wanted to share a summary of that paper just to illustrate what I mean. And we'll go over all those a little bit later as well in the future. But just for now, I just thought if I share with you, this is one of the studies that I was reading. Essentially, what they've done is that they've done a review. And by the way, the DOI and all the information, I'll put it below. So with the link so that you can check it out yourself. But basically, this paper came out in 2019, so it's pretty recent. And what they've done is that they've gone through a bunch of published papers who had used deep learning to look at, EEG data, and they looked at, I think 90 papers. And then they did a review, and then they summarized and made sure to categorize the way in which these type of EEG data, what type of machine learning algorithms would fit best what type of EEG data. So this is very interesting. I highly recommend you looking at it. But if you're not interested in looking at it all, I did a summary of it that I wanted to kind of read with you just so that you can get a gist of it. So even if you're not really interested in this topic, it actually is very, hopefully this would be a little bit inspiring or at least informational for you. So basically, the availability of large EEG data sets that is becoming more and more readily available to people. I think most of them at least are free. It basically has led into a lot of increased machine learning related studies. And because understanding the EEG signals, it's much easier because the type of data that you can basically work on once you start writing your codes. And there is one of the major interesting part with EEG data is to be able to classify them. And so for you to be able to classify them, for example, there are ways you can do it manually, but there are also ways that you can do it, in this case, with machine learning or deep learning, I should say. So the research questions that these scientists had was, for example, which EEG classification tasks have been explored with DL? What input formulation have been used for training the deep networks? And are there specific DLs, deep learning networks, structures suitable for specific data types? And so the result that they came up with was that for EEG classification tasks, there are specific type of neural networks from deep learning that is more robust when it comes to EEG classification tasks. And then they named them here. And as you can see, these are the ones that I'm highlighting. These are the ones that they identified. So obviously you can negate that if you want, but just as an information is kind of there. And then the tasks that used deep learning fell into 5 main categories, or groups, I should say: emotion recognition, motor imagery, mental workload, seizure detection. We actually had Dr. Ulbrich, who talked about the medical aspect of machine learning in EEG with EEG data, and he talked about these type of data sets as well. ERP, event-related potential detection, and sleep scoring. I've never heard of this one, but it's very interesting. It's the first time I hear it. Anyways, so basically the automatic classification of EEG is an important step toward making the use of EEG more practical in EEG classification pipeline. For example, artifact removal is one of the huge headaches when it comes to when you're working, for example, with EEG data set, because even if you are seasoned EEG analysts, not only is artifact removal very manual, but also sometimes, even if you're really good at it, you actually miss it. So that's a huge one that the EEG classification can be used for. And what makes EEG data suitable for machine learning? The highly structured form of an EEG data set, that is a 2D dimensional matrix. You have time and you have channel. These are very clear 2D matrices that are real values that you can add in your codes. Then they actually represent brain generated potentials, which are reordered on the scalp associated with specific task conditions. So these are very important, because if you are new to EEG, you might think, oh, this is like a huge data set and I don't know, I'm not sure how to work with it. But in actuality, when you define them one by one, for example, in this 2D matrix, it actually becomes very tangible, and very shortly you'll be able to sort of sort that out. And if you've never actually seen machine learning in EEG, if you've ever ran an ICA on your EEG, if you're EEG expert, then that is actually in the back end, what it's using is machine learning to help sort of remove some of those artifacts. I did this a lot for my study because I had to remove a lot of artifacts, etc. And so because neural networks automatically optimize their parameters, they are generally believed to require less prior expert knowledge. So in other words, if your background is just coding, let's say computer science, you should be able to pick this up pretty quickly. And then this is the last one thing I wanted to mention to you, is that it's very, very cool, because they, as a result of this lit review that they did, was that they came up with a workflow diagram that will potentially serve as a starting point for any initial architecture design. For example, in future application of deep learning to EEG classification. So if you want to have a starting point, for example, and you don't know, you're not sure where to start, this would be a good paper to start, because I really like the workflow in that. I'm not going to show the workflow, but I think you get the gist of it. Anyways, very exciting times. That's what I mean with everything being extremely exciting. So I will add the link below so you can look at it if you want. And then I highly recommend, even if you don't have any computer science background, or if you don't have any neuroscience background, it's actually these times is very exciting because you don't need to have a lot of money, and you don't need to have a lot of background. You can pretty much learn all this by searching for people on YouTube and just learn it. So hope this was helpful. I'll do more of these, and I'll see you guys later.